Hello guys, welcome back to my channel. I'm your host Asan Khurram, and in this channel, Algorithm Minds, I have been teaching marketing and analytics with Python over the last couple of videos. Today, I'm come up with a very interesting topic, which is customer segmentation. How we are actually able to identify hidden segments of customers with the help of very important and beautiful technique known as k-means clustering. So you might ask me like why is customer segmentation required? So customer segmentation is the process of dividing customers into a group based on their some certain characteristics such as like demographics, purchase behaviors. So we can actually take those demographics, those detail, and actually segment customer based on those things, and then target marketing efforts to those particular customer with their specific message that we do have at hand. So, what will actually help us enable the marketers personalize campaigns, identify high value segments, allocate budget efficiently? So you might ask me, okay, I understand the value of clustering or like segmenting the customers. So what is actually k-means? So k-means clustering is a kind of a very machine learning technique where we use clustering automatically groups similar customers without labels. So we don't really have to identify labels. Okay, this customer segment of group of people belongs to this customer. So it will just take the data, take the characteristics, and based on those characteristics, we will provide some value like how many customer segments I do want. For example, if say that we want three customer segments, so it will take the whole data and say it will divide those data into three segments based on those similarity contexts. Okay, so it will look at the data points, it will assign similar data points to the similar category, and in the same way it will categorize the other categories as well. So this makes it perfect for unsupervised marketing insights. So let's move on and actually look at the uh, practical programming section. So here, first of all, we are going to import important libraries. So we have like pandas, and we have like matplotlib, we have seaborn, and we are also using scikit-learn library, and we are importing function k-means from its module cluster. So that will actually enable us to perform the k-mean clustering. So this is the data set, and these are like obviously some of them would be our characteristics, such as like we have age column, then we have like total value of all promotions, but we can also further go on and add other characteristics as well that will further enrich our customer segmentation. For example, we could add subsequent order count, total value of all promotion. But for this particular tutorial, I'm going to limit it to characteristics, the age column and the total value of all promotions. So here we have separately stored those two columns in a separate data frame and store it in the variable x. Now once we have that thing, so this is what an output would look like. Once we create the cluster column and after performing the k-means clustering, we are going to categorize this into number of segments. Here 2, 1, 3 in the cluster represents a segment. It's a categorical data. It's not something we should assist of integer or type of data. It's kind of resembling a categorical data. Now let's move on and see how we can actually perform k-mean clustering. So it's quite simple and easy to do. First of all, we will create a variable called k-means, and we create its value, and we call the function k-means of scikit-learn library, and we pass two input argument. The first input argument is the number of clusters, like how many segments do you want for this particular data set. In our case, we set to 5. We say that we want 5 clusters out of it, and we set random state is equal to 42. This is for reproducibility, like whenever the script is run again and again, it will have the same kind of results. Then this is the main script where we are actually creating an additional column called cluster in the data frame, and we are using k-means, which we have defined earlier, and we are applying method fit predict and passing x as an input argument. This fits the model to the data and to find the clusters, and then it will predict the cluster assignment for each customer. So it will take every row and it will predict that this particular customer belongs to this segment 1, cluster 1, 2, 3. Now once you kind of predicted those values, one important thing that you can do, actually you can now identify the mean values of that particular cluster. Like it will have some associated mean value of age, it will have some associated mean value of subsequent order count or total value of our promotion in our case. So we will can actually draw them in this particular format. As you can see here, we are creating a new data frame, but the important thing to look here is this particular input argument. The first input argument is actually the way how we can take the mean values out of this k means we have fitted earlier, and this one is just for the renaming the columns. And once we have the centroids, now you can see this is the most valuable information that we will be able to pass to marketers. So we say that, uh, there is a customer segment that has associated value of 38 age, and it has a total value of all promotion 2.5. And later we take this information, we kind of create a filter around this age group and this total value of all promotion, and we would like to see its profit. And you can do this for the every centroid we have created, and based on that particular thing we are actually able to see which segment help us generate more revenue. In that particular close context, we will be able to generate or run ads for that particular segment that generated the most revenue. To graphically visualize it, here's a kind of scatter plot which is being plotted using the function scatter plot of Seaborn library, and we are passing number of input arguments. The first input argument is obviously the data frame, which is the df. The second input argument is the x, defining x and y axis, and here in our case the x axis would be age and y-axis will be the total value of all promotion. Here for hue, in order to distinguish between the different clusters, we are setting hue is equal to cluster. So every row, every dot will be colored based on the cluster that has been assigned. And finally, we are setting palettes color to set 2, and we are also setting the size of dots to 70, and the rest will remain the same. And you can see that this graphically visually appealing that based on those two characteristics we are actually able to segment customers, and you can see that they are being beautifully separated from one another based on the cluster they have been assigned. So just to keep that in mind, each color represents a distinct customer group. Young customer may have low CLV but higher repeated orders. So this is something like you can actually take the information from Centroid and implement on other analysis. An older customer might yield higher CLV but for fewer orders. So if you have like customer lifetime value also associated with this analysis, then you can come up with such kind of outcomes. So I hope this tutorial is helpful. If you have any question, feel free to write down in the comment. I will happy to help you out.